Hello everyone, welcome back to my channel. My name is Dr. Mohit Sharma, and in this video we will see the Q-learning implementation in Python. So this will be very interesting video, and by the end of this video you will see how we can make the agent learn in a very complex environments. Okay, so let's get started. So if you have not seen my previous videos on Q-learning, then please watch my previous videos in which I have mentioned about the theoretical implementation of QL. Okay, so to begin with, we need to import some libraries, right? So let us import the NumPy first. Import NumPy as NP for our numerical calculation, and then we have to import Gymnasium library to fetch this reinforcement learning environment. So import Gymnasium as Gym, and for plotting purpose, we need to import matplotlib. Import matplotlib.pyplot as plt. Okay, so we only need these three libraries. Okay, and then from this Gymnasium library we can fetch this particular environment, which is a FrozenLake environment. So it can be fetched like this: env.gym.make FrozenLake -v1. Okay, we have to add the name of this environment, and then is slippery equal to false. Okay, so with this one line of code we are done with our environment, and now in the environment the states and actions are already given. So we need to see the state size and action size, okay, that we have. So the state size will be given by state dot observation environment dot observation space dot n. Okay, so we can see that total number of states are 16, and in this cell also, in this image, the total number of grid cells are also 16. So each cell represent a particular state of the agent of this environment. And then we also need to mention the action size, like how many actions the agent has. So action size is env dot action space dot n. Okay, so we have four actions which are left, right, top, and bottom. Okay, so based upon the state size and action size, we have to initialize our Q table. In that Q table, for each state we will have four actions. Okay, so there are 16 states. So for each of these 16 states, we have four actions. Okay, so first we will initialize Q table with zeros only. Okay, so state size and action size. So you can see we have 16 rows and 4 columns. So for each state we have 4 particular actions. So currently all the values are 0. So there is no such preference for any of the actions in any of the state. Now after initializing the Q table, we need to set some hyperparameters which are given in this update rule, like alpha and gamma. So alpha is just the learning rate. It tells you how fast the agent will learn. Okay, and then gamma will tell you how much importance you will give to the farthest rewards as compared to the nearest reward. Okay, so gamma is equal to 0.95. Okay, you can take any value between 0 and 1. And then we also need to set one more hyperparameter, which is epsilon. So it will tell us how much the agent will explore before exploitation, or before gaining confidence of choosing the best action in a particular state. So initially let us say epsilon is equal to 1, and with time it will decay. Okay, so we need to mention the decay rate, which is, let's say, 0.999. So larger the decay rate means it will slowly decay. So it will more explore the environment, and it will decay up to the minimum value of epsilon, which is this. Let's say it is 0.01. Okay. So now we also need to mention the number of episodes that we have. So the number of episodes for the training, let's say it is 5000, and within each episode there could be infinite number of steps. So we have to put the upper bound on the number of steps. So let us say max steps are 100. Okay. So we have also set our hyperparameters. Now we need to do our training. Okay. To do our training, we are only worried about our reward. Okay. So after each episode, we will store the value obtained for total rewards. Okay. And then that value will be stored for each and every episode, and then finally we will plot it. Okay. And we will see if rewards are improving or not. So we will initialize the rewards as a list or an empty list. Okay. And now for each episode we have to run a for loop. Okay. So for episode in range episodes, uh, we need to first mention the state of the agent, like in which state the agent will be when the episode initializes. So let us say the state will be just the reset state. Okay. And initially the reward is also 0. So total reward for that episode is also 0. Okay. Now for each step we need to mention whether the agent will explore or it will exploit. Okay. So for each step we have to mention all these things: the exploration, exploitation, how the Q value will get updated, what next state the agent will get, okay, whether the episode is done or not. So all of this logic we have to put for this particular step. Okay. So we have to run a for loop for the number of steps that we have. So for step in range max steps. Okay. If any random number that we will generate, so np.random dot rand, if that number is less than epsilon, okay, then the agent will only explore. So it will only take the action by randomly. Okay. So action is just the env dot action space dot sample. So it will take any action out of this action space that it has. Otherwise, it will exploit. So it will take the best action based upon the highest Q value for that particular state. So np.argmax Q for that particular state and for all the actions. Okay. So this will give us the index of which the Q value is maximum in a particular state. So that index is just the action. Okay. Now based upon this action, we will get the next state reward, whether the episode is done or not. Okay. So all of these things can be fetched from env.step action. Okay, we have to pass this action in the argument. Okay, it will give us the new state. Okay, new state reward, whether the agent will get any reward or not, whether the episode is done or not, Okay, and then based upon the new state and reward, we can find the Q value for that particular state and for that particular action. So Q value for that particular state and for that particular action can be updated like this: Q state comma action, okay, plus alpha times reward plus gamma times the Q value for the new state. Okay, so now it will take the maximum Q value for the new state. So it is np dot max Q new state, okay, minus Q of this present state and action. Okay, so this is just the same formula as this. Okay, and after defining Q value for that particular state and action, uh, the present state will get changed to the new state. Okay, so the new state will become our present state, and we will sum up the total reward that we will get. Okay, so total reward is just the sum of the reward that we will get after taking each step. We will also check if the episode is done or not. If it is done, we will just break. Okay, so now we need to mention how the epsilon value will decrease with episodes. Okay, so epsilon is equal to max of minimum epsilon or epsilon times decay rate. So whichever is higher, that value will be attributed to epsilon. Okay, and then we have to append the total rewards in this final list rewards. Okay, so rewards dot append total rewards that is accumulated. Okay, so this is it, and now we have to just add a print statement to check if the training is completed or not. Training is completed. Okay, so let us run this cell. So yeah, the training is done. Okay, and now we need to plot the rewards with episodes. So rewards if you will plot the reward with episodes, then it will be highly oscillating, because in some of the episodes it is 0, or in some of the episodes it is equal to 1. Okay, so that is of no use. So the better way is to choose the moving average. Okay, so we will take the let's say 100 values of rewards, and based on that reward we will see what is the moving trend. Okay, so this is better in visualizing the growing of the rewards. Okay, so for this we will just use np.convol in plotting. So plt.plot and then just np.convol. Okay, for the rewards. Okay, and then np.ones. So we will create the one values 100 times, divide by 100 to normalize it. Okay, mode equal to So this will give us the moving trend of rewards, okay, for different episodes. So in the x-axis we have episodes, plt.x label is episodes, and plt.y label is just the average reward. Okay, we are not using the actual rewards. And then plt.show. Okay, so let us check. This is also fine. Okay, Q state plus alpha times reward plus gamma times anti max dot q next new state minus q state action state equal to new state total reward this epsilon is max minimum epsilon rewards dot append total reward. So yeah, so it should be total reward. Yeah. So now training is done. So yeah, so you can see the rewards are increasing with number of episodes. So around episodes 5000, the rewards are saturating to around the value of 1. Okay, so now the training is behaving perfectly. So now we have to check whether in the test phase we still get the reward equal to 1 or not. Okay, so to test this training, let us initialize the state of the agent again to the reset state. So the state of the agent will be the reset state. Okay, and we have to mention whether the episode is done or not. So done, let us say it is false initially, and total rewards are 0. Okay, and then we have to run the while loop. While not done, in this testing phase we only choose the action based upon the q value. We will not explore. So the action will be just np.argmax, okay, q of this state with all the actions, okay, and based upon the action that agent takes, it will reach out to new state. Okay, so new state comma reward done equal to env.step, right? So this will give us the new state, the reward that it will get, whether the episode is done or not. Okay, and then we will accumulate the total rewards plus equal to reward. Okay, and then we have to print total rewards. Yeah, so total rewards are equal to 1. It means in the testing phase also the agent is choosing the right path, okay, and it is not falling into the pond. So if we need to check which states the agent has taken, so we have to add a print statement here to check through which state the agent passes through. So it is passing through the state 4, 8, 9, 13, 14, 15. Okay, so let us see in this picture. Currently the agent is in the zeroth state. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the agent will take this path, right? So it is not falling into the pond and it is choosing the right path, okay, and it is also the fastest path. So we have successfully done this training, and in our testing also the results are coming fine. So if you like this video, then please hit a like button and please subscribe to my channel and share with your friends. I will see you in the next video. Thank you.